coordinate plane.
All right, let's do some math.
Sir, I have many questions.
Many.
Some of which you can't answer, but I have one that you can. I have hundreds. What is the answer to number 12?
I can answer that one.
All right, and maybe 10, but I only want because I've probably already figured that out. But I still want
12?
Because 10 was annoying. 12.
All right, let's take a look at number 12. I don't think I did that one in the other class.
12 was weird. It was not like hard weird, like weird.
I guess hard.
What?
Did anybody notice the pattern in the table?
Yeah.
What was the pattern?
You just same for the top two in this square.
There you got
Sir,
it. So
I'm not.
you can absolutely already look at your answers and tell me if you got them right or wrong.
Yep.
Hey, sir. This is
That's
funny
only one
that
through
we're at
eight.
funny that we're at 11.7.
Why?
Why?
Well,
Well, what's funny?
Is it more like irony? Why is there a
I
character?
can't find.
Because
Wait.
11 plus 7 is 18.
Oh, I was looking at 11.8 dash 8. I was going, where's the homework? Never mind. Don't listen to me. I'm an idiot like always.
so you're saying you don't have question 12 as a question?
No, I do have question
Okay.
12 as an answer. I'm trying to find where
Question 12
was.
says the lengths of two similar triangles. So we have similar triangles. Therefore, we know that the area ratio should be the scale factor squared.
Yep.
Two similar triangles are x squared and xy. What is the ratio of their areas? So let's see. So if the scale factor would be x squared y, or xy, sorry. And what do we have to do with that?
Well, there's a problem. It says the length.
Remember, scale factor will be any two corresponding measurements
Right.
written as ratio. What am I going to do with that?
Square them both.
So that gives me x to the
Fourth power.
over,
XY squared.
X squared y squared.
which would reduce to,
X squared over y with x over y.
no, you had it right first.
X
X
squared
squared
over
over
X
Over
over Y squared. Yeah.
Wow, I can't write to the, yeah, there you go.
Okay.
The
And
book
then
likes to write it in colon form, but there's in ratio form.
I always write them colon form. Why do you write them ratio?
I mean, colon form would be the statement. What is the ratio? The fraction would be if you're actually going to use it to do some math. Either one's fine, by the way. All right. Anything else?
I do number 10, but I already know the answer to that.
The areas of two circles
okay,
are 36 pi and 64 pi. What is the ratio of their diameters
And circumferences.
and circumferences?
Yeah, but that's the same thing.
It would be the same. So what do?
You just reduce.
Put right as a ratio and reduce it. That's it.
Oh, that's what I did, I think.
So you got
The wrong answer. I got like,
pi's would cancel out.
right, the pi's would cancel out, and then you would take the
4 goes both into both of them.
How about
Yeah.
12?
12.
Yeah, 12.
12 is better because then you get 3,
Well, 4 does go into both of them. I wasn't wrong.
3, 3. 12 does not go into both of those. 12 does not go into 64. That's a math mistake.
12 doesn't go into 64. What do you know?
That's a
So
math
what-
mistake.
So what does? 9. No.
No,
How about
8.
How about
Just
4?
kidding. 4 is the biggest number.
4 is the biggest
Nobody
thing?
listens to me.
8, and then you get 16.
Oh, 12 doesn't. So what do you get?
You get 9 to 16. Then you, because we know their areas, we gotta,
Take the square root.
yeah, and then that guy is 3 to 4.
3 to 4.
What about, I just in a completely different for circumference. Because I thought it was something separate.
Well, just remember,
Circumference would be 9 to 16.
because there's nothing being squared there, it's just 2 pi r. It's the same basic idea.
Right.
So you can take any two corresponding parts and
Right.
write as a ratio. So you would still get the same thing. 3 to 4.
Wait, there's a 9?
The only time you get something different is when if you did the ratio of the areas, because you got squaring going on.
Oh, I understand it now. Okay.
Because circumference is 2 pi r, not 2 r squared.
I'm just gonna cross out my second thing so there's no correlation.
All right, anybody else?
B squared. The worst you could mess it up would be like 2 pi b
Yeah, you
squared.
got it wrong. There's a ninth circle after 8.
We said that, treachery.
What?
I thought we only went to 8.
Well, I don't know. I just pulled something off the internet, but it
What?
said the ninth was treachery.
What are you talking about?
Dante,
Oh,
Okay. Yeah, I'm looking at the book. and I
yeah,
thought
there
it-
is 9.
I thought there was only 8. I thought it said 8 on the thing.
well,
Oh,
it,
It
yeah,
was
but it
actually
cut
not
off.
the last one.
They cut it off. All right, they cut off the last.
That's where Brutus, Cassius, and Judas went.
Oh, yeah, geez.
Yeah, so you got to do something. You got to be really bad to get down there with those winners, right?
Challenge accepted.
I don't think I read it freshman year. I think I read it sophomore year. If I remember right.
I'm technically a sophomore, so.
Almost.
You're technically
All right, here we go. So if you didn't notice the pattern for the table was the first two, the scale factor and the ratio of the perimeters were exactly the same. And then the ratio of the areas, we just simply take the scale factor or the ratio of perimeters and square it. So really quickly, I'm just going to call it the answers. Number 1 is 1 to 4 and 1 to 16. Number 2, 3 to 2, 9 to 4. Number 3, R to 2S and R squared to 4S squared. Number 4, 9 to 5 and 81 to 25. Number 5, 3 to 13, 9 to 169. Number 6, 5 to 1, 5 to 1. Number 7, 3 to 8, 3 to 8. Number 8, root 2 to 1, root 2 to 1. We already discussed 10. There was 3 to 4, 3 to 4. 11 is 1 to 2, 1 to 4. Why are these different? L, M, and N are
You
midpoint.
didn't do number 9.
I did. Oh, I'm
No,
sorry.
you skipped
A
it.
ridiculously huge number that is too large to even write. How about that?
9?
What did you get?
1 to 25 trillion.
I got 1.
I'll go back to my previous statement.
I wrote all the zeros.
All right. Why is number 11 not the same answer? L, M, and N are the midpoints of the sides of triangle ABC. Find the ratio of perimeters and the ratio of the areas.
The ratio of the perimeters and the ratio of the areas.
Oh, duh, squaring both. Okay, never
Yeah.
mind. Never mind. I'm like, why aren't they the same answer? I got it. I was thinking circumference again. Okay. And then we did 12, which is x squared to y squared. You guys did 13 and 14 okay?
Yeah, kind of.
All right. Why are the two triangles similar?
For the first one, we got angles because of vertical angles.
Yep. And the second pair of angles, this is the harder one.
Is that they share the same
You know,
arc. Share the same arc.
So when you have
Yes.
two inscribed angles and they both describe this arc right here,
then they're congruent.
it looks like that. So that goes to that arc, and so does the other one. So these two angles right here would be congruent, and then you got your two vertical angles. So you got an angle length. Okay. And then there's, 3 different ways of naming those two triangles. So as long as you name the two triangles are similar, you're good to go. But it doesn't ask the ratio of their areas. And then find DE. So the ratio of the areas, 36 to 25. And to find DE, what would you have to do? How'd you find DE?
I just use the properties.
No, once you find that their
Similar.
ratios are 30, it was a 36-25, I said?
Yeah.
And then you're given one other, the side that matches up with DE is, what would match up with DE?
No.
DE would be AE, and AE is 8, and which one is the 36?
36 is the bigger one.
Okay, so,
A, B.
and 8 would be the bigger one. So 8 should go there, and X go there, just do some cross multiplication. Ugh, that's ugly.
36
It was
times
very ugly.
So that's what, carrier 4, 16,200 over 36, and that would reduce to, oh, good Lord, 100 over 18, 50 over 9, is that it?
Yeah.
And the book says the answer is 6 2/3, is that right?
Yeah.
5 goes into,
What you can do is you can
no,
go.
that's not a 5, that's a
It's a 9.
9 goes into
You can do
5.
45 and then
We got the wrong answer. 6 2/3 according to the book. What did we do wrong? 8 times 5 is 40, carry 4. 8 times 2 is 16 plus 4 is 200 over 36. That'd be 100 over.
No, it's
8.
20 over 25, not 36.
I did have 36 over 25.
It's over 25, right?
36 to 25. That's what I wrote
You wrote,
right here.
yeah, so the bottom is 25, not 36, right?
That's what I wrote.
Right.
What are you talking about?
The second fraction.
Oh, I'm just doing cross multiplication. So where's my mistake?
You take
9. 50 over 9. That would be 5 and 2/3, not 6 and 2/3. I got a mistake here somewhere. Did I put the 8 on the wrong part?
that's what I'm thinking, because you're trying to find the. Or you are trying to find the smaller one. Yeah, you didn't do anything wrong.
36 to 25 would be the smaller, and we are trying to find DE, which is the smaller of the two. I don't know. I got a mistake here somewhere.
There's a mistake in the
Why?
ratio then. In 36 to 25.
Unless we're matching it with the wrong side. What if we matched it with 6? Would that give us the right
Yeah.
answer? Am I just matching it with the wrong side?
Maybe.
Try
Calculator,
doing,
somebody-
try
it's too
doing
low.
x over 6. Wait, no. Why would we do 6?
Well, that's the other side of the.
No, it's not the wrong
No,
side.
you're right. You're right. It is 6.
Why would it be
Why
6
would
and
it
not
be-
8?
Because it's HEB to CED.
DE would match with AE
Or no.
because I'm matching
No.
angle C and angle B.
No, it would be AE, yeah.
Yeah.
It should match. This might be a mistake in the book. I'm saying it's 5 and 2/3, not 6 and 2/3. I don't know. I mean, the book tells me the answer, and it also says that the two similar triangles are ABE and DCE. So DE would match with AE, and that's side length of 8.
I don't understand what we did wrong when they did.
Well, I got the
Well,
same
you might
answer
never
as what's on
truly
there on the
understand.
board, so.
Right,
I
yeah.
don't know. I think mine's right in your book wrong.
Well, hopefully 14 isn't wrong.
Well, let's see. 14, the two triangles, exactly the same idea. You got vertical angles and then
Same.
inscribed angles that describe the same arc. So you get 100 to 81, 100 to 81. Yes or no?
Isn't it?
Yeah.
All right, so let's see if this math
Yeah.
works. If this math doesn't work, then we are doing something wrong. All right, so I got to find DE. DE would match with,
So it's 100 over 81 to it would be
ACD,
wait, what?
AEB. Oh, they're doing those big triangles.
Well, this isn't that hard because you just literally
Oh,
take.
this was
Yeah.
actually harder because I have to do the
Wait.
whole thing and then
Well, yeah, it's the big one.
subtract 10 from it to get to the
True.
D. But the previous one wasn't like that. All right, so if we do that whole thing, I got to find AE. And AE matches up with AC, and AC is 20. And AC is on the triangle, on the 100 triangle. So that would be 20 over X. Calculator, somebody?
Getting it.
81 times the 20 is 192. No,
It's like I didn't zero.
160.
1,620.
So 162.
162,000.
Over.
Actually, 162 over 10 would be the same thing. It's the
Oh, I got 2 zeros. You're right. You're
Yeah.
right. You're right. You're right.
so it would be 162 divided by 10. And then we can just
We could just do 16.2.
yeah. Where the books are.
The answer's
Not this.
162.
Not
over
this.
16.2.
Yeah.
I got 16.1/5.
All right.
That's
So we're going to start off with the triangle. So they're saying that triangle ACD is similar to triangle AEB.
There's like 3 similar triangles pairs out there. Though, so.
I agree. Now, why do they choose? The reason why they chose those is because of the numbers. Notice we can't do the previous technique because there's not numbers on those triangles. So we got to use the larger of the two triangles for that particular one. We still get angle E and angle C are congruent. And we still get angle B and angle D for describing things. So they are congruent. And they're claiming it's 100 to 81. Now, where are they getting that? There's got to be a base and a height. So where are they getting
it's DA and BA?
So where are they getting the areas? Find the ratio of the areas.
Because they're using this scale factor for both of them as in DA and BA, which are the two small sides of both of the triangles. And then they're squaring those.
So they're using 10 and 9. Okay, that makes sense. So 10 and 9. So 10 is part of ACD.
So we get 100 over 81.
So 10 is that one, and 9 is this one. And we want to find DE, which is actually part of ABE. So this is the one that DE eventually we're going to find. That's the reason why I'm getting the wrong answer here. Okay. That's the reason why. Because I was thinking it was on the other side. I thought it was on this triangle. Okay. And this one had a,
79.
oh, that's why we got to flip it around. We got to flip it around. That's why.
Wait, where are we getting
They're claiming 8 is the answer. So that would mean the side is length is 18. So we got to get 18 as the answer when we throw this in here. 18 is the answer. And we would get 18 by, gotta match up the right side. So AE would match with AC, and AC is 20. Where's my calculator? Yeah, that doesn't work. If we do it the other way around. That doesn't work either. All right, let's table this one. I will investigate this one and give you a better answer. This is why the other class didn't call this out, because they probably didn't do it. Because if we can't do it,
Then they can't do it.
I guarantee you they didn't do it. All right. All right.
Want the homework?
No, I want to solve that problem first, is what I really want to do. But
Yeah, dude.
Yeah, we got time.
we don't have time.
Class.
I thought we had like 20 minutes left.
Well, we probably have plenty of time because this is a pretty short class.
Oh,
Okay,
okay.
good enough.
Enjoy.
There's only one of these
Ooh,
problems that is
GMS
difficult.
me.
Oh, this is the, wait, we haven't.
We're going to
done
do
these
something
since
called
algebra.
geometric probability.
We haven't done word problems since like algebra.
No, every problem in geometry is practically a word problem.
Oh, well, none like this before. Okay, you kind of got me there,
What's the homework?
You guys are up on the one change with TSAT? Unfortunately,
but. Oh,
no day off.
What? What? What?
So we will have we'll do our chapter review tomorrow. We'll take the chapter 11 test. We'll do 3 days of TSAT prep. Originally, we were going to take Monday as one of the off, but we're not now.
We're not, do I at least get Thursday? No.
You get Wednesday.
Is it a half day on that day?
Tuesday is a half day, and Wednesday you're at home.
Oh,
Baloney. This is rigged.
yes, I get it.
So that was, they never told me why they made that change. I'm not
Yeah,
sure
that
why.
doesn't make sense. I would rather have it.
So would we. All right, here's your homework.
Oh, are you tired of kids?
No,
No.
but if you gave me the choice of do you want to teach or do you not want to teach, what would be the easy question or easy answer?
I want to eat
No.
ice cream
Yeah.
at home.
Isn't it because I'm doing CMS testing?
That's what I'm saying. But so I don't. Maybe it was because everyone was testing, so there's no conflict now, so we can have class. I guess that was my assumption.
Well, if I got Monday off, and that means I could do all the things I was planning to do. I was planning to cook shrimp again.
How are you going to cook them?
This seems like an easy class.
This is an easy class.
Yeah, that's
seems
why
like-
it's gonna take
No.
us 10 minutes, and you guys are gonna argue about the best way to do that problem after.
The only one we're going to argue is the very last one.
Which one? Number
4, I'm
That's 4.
guessing.
If you want to argue, you can't look at the book then.
Well, I was just
Well, I'm not arguing. Can I look
All
at
right.
the book?
Geometric probability, but you can't answer the question when I ask it.
All right.
There's only one that really requires some deep thought, and it's the last one.
Oh, philosophical. Or,
All right. Remember doing probability pre-algebra?
I love that class.
Do you remember any part of it?
No.
What's the probability of rolling a 6 with one die?
6.
A
Four.
one in 6 chance, aka a 0 point. I forgot the number.
1 6
17%.
18. Something
1
like that.
6 1 6 1 6 6 6 6 6
So about
6.
17%. Okay. You probably don't remember this. Write this down, box 1. Events. Events are you play a game. Events are what happens when you play a game. So, for instance, rolling a 6, rolling a 4, rolling an even number, right? It's a possible outcome. Now we say game. It's a whole branch of mathematics called get. Did I hit record?
No.
Sorry, Madison. Yes, I did. No, we're good.
Oh,
It's a long day. Can't even remember turning it on. Events are there's a whole branch of mathematics called game theory, and yes, it is on the surface about games, just really about life. Game theory. You know, you could say walking down the hallway is a game, right? In life, and there's many things that could happen. Events could happen when you walk down the hallway.
like
And the branch of game theory and probability is about calculating those probabilities.
all right, what's the probability of a raptor attacking me in that hole?
Very zero, close to zero as possible.
Okay.
All right. A game, if I define a game as rolling a die, that's a game cube, right? Then the event, one of the possible events would be like rolling a 6. Okay. Today we'll be calculating probability, and that's the chance of the event occurring mathematically, the mathematical chance of that event occurring. And you've done these before. There's nothing like literally in pre-algebra, they're doing exactly the same thing right now. The difference between them and you is you will be calculating the probability of a geometric event.
Oh, I wanted the probability.
If you need to write this down, write this down. This is the only formula that we will need. It's a ratio, and it's a ratio of well, how many ways can you win the game over how many things can happen when you play the game, except they don't use the word win. They say the number of ways that event could occur. Notice the probability of getting a 6 on a game cube is 1, but the probability of rolling an even number, well, there's more than one way to win that. 2, 4, or 6 wins that game.
So you get probability of 4. That'd be 3.
Even number?
That's an even number.
What would be the probability of rolling an even number?
About 3
Out of,
6.
so therefore,
36.
which is,
What fits into both of them?
Sorry. 3.
3/6.
Yeah, 3 goes into both of those.
So
So you do 3 times 6
So
times
what?
3 times 9.
what is it?
9 over.
No, I don't know what you're doing.
Wait,
One over 2.
Reduce the fraction.
What do I have to do? 1/2.
All right, so 50%, right? We generally, even though probability is defined as a fraction, we generally like percentages. The book, all the answers, I think they just put them in fraction form. Yeah, it looks that way. I would prefer if you put it in percents. Even if it doesn't say that, 3/19, what the heck does that even mean, right? 3 out of 19, right? But we would much more likely, we would like to see that as a percent. Okay,
Can you turn that into a percent?
you can. Top divided by bottom times 100. Top divided by bottom times 100, which is why 1/6 is,
It's
we just already said the answer here.
it's a
What they were arguing about,
20 to 50%.
17%. And that's rounded, right? Okay. So probability of rolling one die, what's the probability of rolling a 4?
1 out of 6.
17%. Okay. Probability of rolling an even number,
50%.
50%. Probability of rolling a 1 or a 4.
2%. Starting 2 over 6. Which is, okay, 1 over 3. You divide 32. Probably, no. 3, 0.
No, it's just 1 over 3, so it's 33%.
33%. Okay.
Really? Yeah, I could have gotten to that answer.
You were close.
You didn't, though.
All right.
I was.
All right. The but here is today we're not doing this type of probability. We're doing probability for geometry.
Oh,
Okay.
God.
So there's going to be a geometric shape, and somehow we're going to be getting a probability from the geometric shape. Do not panic It's pretty simply done. So here's as simple as it gets. This is one of the questions tonight for homework. Well, what's the geometric shape?
A line.
That's not a line.
A segment.
It's a segment, right? You might say there's 3 segments there, but there's at least 1 segment there, right? So you have a segment, and then you're going to have some words. Read, Jack.
Oh, if a point on AB is picked at random, what is the probability that is point AC?
So I close my eyes, and my finger will always, I got to make sure I can do this, always touch the segment. So what's the probability that a point at random, where you land, right? Now, the caveats here are that you have to land on a line. So you are picking a point on that line.
Yeah, but you could land on a point.
You could,
You could land on C,
and you're still, that's inclusive, so it would include that, right?
but it would also be in CD.
Yeah, that's true.
It would probably
That
be
is
2
true.
over 1, wouldn't it? Because AC takes up more room than CD.
So intuitively, we get this basic idea that,
2 over 1, 1 over 2,
well, no, I mean, just throw out a number. What do you think it's going to be?
2.
8 over.
Yeah, but it would be a percent.
Yeah, 8 over,
No,
it's
5.
about 75%.
So our guess intuitively, just looking at the shape, somewhere around 75%. Well, it turns out we can calculate this using that point. I mean, it's still the same basic thing. So to win this game, where must you land?
62.5%.
Where must you land to win the game?
AC, somewhere in AC.
Somewhere in AC. Well, how long is AC?
5,
And how long is what could happen if we land anywhere?
3.
No.
If you land anywhere.
Well, it says on AC, I'm sorry, on AB.
Oh, you can land in CB.
If a point on AB is picked at random.
Okay.
So you're landing somewhere on AB.
Yeah.
Well, how long is AB?
Oh, it's 8.
So what's our fraction?
5/8.
So that's our fraction. Jack already grabbed his calculator and found out it was
I just did it in my head. My calculator's dead. 62.5%.
62.5. Oh,
I've got all of them.
reminder, I'm gonna be telling you this for the entire week. You must have a charged graphing calculator for the test on, what is it, Tuesday? Tuesday. You must have a charged graphing calculator on Tuesday.
Sure.
I think I'm gonna retake.
Jack's just gonna bring a different one
All
so
right.
he keeps his memory.
Another example. I don't know what this is. The other period said it was a golf course, and there's the water hazard right there.
It looks like a factory.
Yeah, it makes sense. A golf course with
So
water hazard.
what's the probability that you land in the water? If you land in that region.
Like 95%
It
for me.
seems that way, right?
25%. About.
Okay. Well, what's
Approximately 17.
the difference between this problem and this problem?
Oh, we have
Besides
no,
one is distance, one's area.
we have no defined area.
Well, yeah, we do perfectly well defined
Well,
areas.
we have no variables.
I like the way you're thinking, but
Values.
values, right? So we have no values here, but we could still write the probability. So what's the probability?
R over S.
Yeah, but what is R and what is S?
They're R and S.
R over S plus R.
S is defined as the whole thing.
Oh, okay. R over
So
S then.
R over S.
Yeah,
Yeah.
but what is R and S?
R is
R is the
25
length
and
and
S
S
is
is the-
75.
Is everything.
Yeah, but those are just letters.
R is every. Yo, what do you want me to do here? We don't have any values.
I know we don't. That's the problem.
Yeah,
So
we
we're
don't
just
have
giving
anything.
variables. So it's just R over S. That's the
Well,
best
what
we
were
can
these
do.
numbers? What do they refer to?
The line, but I'm just giving you.
Refer to
Points.
distances, right?
Yeah.
So what's the difference between this picture and this picture?
There is
Besides the
no
fact there's no
distance.
numbers.
There is no distance.
Yeah, but what's the general difference between this picture and this
A
picture?
line versus some sort of.
A line versus,
A
A
circle.
polygon.
Oh,
well, we wouldn't call that a polygon, but
I don't know what you're
a
calling it.
cube.
how about we call it a region?
Oh, I like cube.
So how do you measure a region?
you grab a
S.
ruler and go across.
Well, that's the name of it, but how do we measure that region?
Area of S.
So then what's our probability?
Area of S over area of R over area of S.
And that's what you would do. Now, I left off the words, but that basically kind of gives you the hint there. If a point on the region S, that would include the water, is picked at random, what's the probability that you land in the water? In other words, region R, that would be, well, the way you technically win this game is to land in the water, so that would be area of R over area of S. Make sense?
Okay.
And like I said, today's a pretty simple day. It's not that complicated. Just got to be able to wrap your head. So those are the easy ones. You should been able to get those. Now we get to, they're not that much more challenging, but this one's a bit more challenging. All right, McKinley, read.
Every 10 minutes, a bus pulls up to a hotel and waits for 2 minutes while passengers get on and off. Then the bus leaves. If a person walks out of the hotel front door at a random time, what is the probability that the bus will be there? All
So
right,
not only is this a useful thing, I mean, this is done in real life all the time. You know, if you're a business person, you want to make sure that, you know, you figure out, well, what would be a good wait time? 90% of their time they're spent waiting, 50% of their time waiting, 10% of their time is waiting. You kind of get that number, and then you arrange your schedule to make sure that this occurs. All right. Now, this doesn't seem like geometry, right? Maybe there's a building or a bus. There's some geometry there. But intuitively, there's not a geometry here. So some of these problems are going to force geometry onto the problem.
Why?
Well, one, it makes your understanding of this one a whole lot easier. Now, this has really easy numbers, but if the numbers got a little bit more challenging, then maybe you could see the usefulness of this geometric picture that I'm about to draw. Okay, so the but here is that there's no geometry going on here. We got to force some geometry on it. So I'm going to force the geometry of this thing. It's basically this problem right here, just the numbers are slightly different. Okay.
All right, so
What are we dealing here basically? Are you dealing with money? Are you dealing with distances? Are you dealing with time? Are you okay, so we're dealing with time. So when you hear the word time, what's your natural instinct to do?
count it.
To count. What else? To draw.
A clock.
Clock. What else to draw if it's time? You do it in history class a lot.
Oh, the diagram.
Yeah, but what does that have to do with time?
You draw a sequence of events.
Sequence events, right? So a timeline, right? So how about we draw a timeline, right? What would be the first thing we put on the timeline?
Every 10 minutes, a bus appears.
So what's the first thing that has to happen?
The bus has to appear
So where is that going to happen on a timeline?
in 10 minutes.
In 10 minutes, a bus appears?
Yeah, and every 10
Now.
minutes.
So what's now mean on a
Now
timeline?
Now means the very beginning.
So we're going to call that time.
Now.
Numbers, time.
1,
Well, 1 isn't where things start.
10,
12,
Where do things start on a number line?
0.
Start at 0.
Well,
negative
yeah.
1.
I got you.
There is no 0.
Third-
So
13.
in science class, have you ever heard of time 0, t sub 0? They say null time, right? So in any experiment, you always have t sub 0. That's where your experiment begins, right? All right, so same thing here. We're going to do a timeline. So 0 is our starting point. And what happens at time 0?
The bus appears.
Okay, so how long does the bus stay there?
2 minutes.
And how long does our timeline go for?
Indefinitely.
Does it repeat itself
It does
Yeah,
repeat
it does
itself.
every?
10 minutes.
So what does my timeline need to go
12
to?
minutes.
Oh.
It repeats itself every 12 minutes.
12 minutes to repeat
Because
itself?
it has the 10 minutes to get there plus the 2 minutes it waits before it leaves, meaning 12.
Where does it say it takes 10 minutes to get there?
Every 10 minutes, a bus pulls up at the hotel and waits 2 minutes while passengers get on and
So
off.
does it say every 10 plus 2 minutes? Or does it say every 10 minutes?
Fine, I understand.
2
So
minutes every 10 minutes.
What?
every
How
60
long do you
minutes,
want
that's
me to
12.
make my number line now?
12. No, 60. What do you mean?
Let's make it 30.
We can make it any time we want, but I'm just saying, why are you drawing repeated things that happen over and over again? Let's make the shortest timeline possible.
10.
Okay, is it 10 or is it 12?
I think it's 12.
Why is it 12?
Because once it gets there, it waits 2 minutes before it leaves. Meaning that if it waits 2 minutes and this is over and over again,
But
it-
every 10 minutes the bus pulls up.
fine.
Doesn't
10
say every
minutes.
12, it says every 10. So let's go to 10. And it said that it pulls up and waits for.
2 minutes.
2 minutes. Oh, okay.
So now I have a picture that represents, and you'll see this problem pop up in a whole lot of math books. Obviously, they'll use different numbers to make it more challenging, but this idea of something happens repetitively, it doesn't change, and somehow you can get either a probability or maybe some more data from it. Okay, so yellow is going to represent what?
How long it
When we
stays
need
there.
to get there.
Okay, so this is that same thing. Now you pick a point at random. What's the probability that the bus is where you're at?
2 over 8.
Over 10.
2 over 10. Yeah.
Because remember, the bottom number represents everything that could occur,
Wow.
right? So 2 over 10, therefore, what's the percent?
1, 5. Then you divide it and you get 0.2, which is 20%.
It's just 20%. So 20% of the time, there's a bus waiting for people. Okay. I don't know if that's a good thing or a bad thing. If you're a business owner,
You don't really
That would
know it's
actually
hard.
make it harder for you to reduce. it.
Yeah,
It's
especially some of the
2 over 10.
homework ones, you do not need to reduce it.
all right. Yes, got it.
Yeah, got it.
All right. This is the other one that you will see all the time. I don't know. Geometric probability, I would make a 99% chance that it will always be an archery target. Always.
That's dumb.
All right. So you will see an archery target. And it'll be something about geometric probability. Sometimes they'll do a dartboard, right? Okay. That's a lot of words there. Yeah. What's the key thing as you're reading that you see?
I don't like probability.
Okay, so it doesn't matter where the archery, the arrow lands, is it equally likely to land on one spot? With an expert, they're more likely probably to hit a bullseye. But with an amateur, okay, there's equal likely is to hit anywhere on the target. Okay, there's one key point. What else do you see? What's key to a beginner? So did this person miss?
Probably.
What does it say?
Well, is the problem if a beginner?
If he shoots the arrow and hits the target.
And hits the target. So we are excluding the fact that, most likely he might miss the target. We're saying that he hits the target. So if they hit the target, what's the probability they get a bullseye? And then there's some numbers.
A 1/3.
What do those numbers mean?
How often they hit that area?
Yeah, this one's not described very well. There's just some random numbers there. What do you think those numbers mean?
What, how often he might hit those? Like one is how one
Okay.
out of a 3 chance is
All
how
right,
much
maybe.
he hits it? Yeah.
What's more likely, though, because of those lines
The
next to it?
diameter, the radius is.
Right. Without those lines, I even might buy into that. Maybe it's the points for each one because I don't know anything about art. I mean, I do, but I'm saying maybe the person doesn't know anything about it. Maybe they think you like golf, you get fewer points is better, right? I don't know. But then you got this 2 and 3 next to it. Those lines are what give away. Those are the radii of those concentric rings. Okay. So we got concentric rings. You're just as likely to hit the bullseye as the outside. By the way, is the area of the concentric circles the same or different?
No, they're the same formula.
Okay, but do you think the areas of the concentric circles are the same or different?
Different.
They have to be different, right? You ever notice anything about an archery target? The distance between each concentric is exactly the same. In this case, 1, 1, 1, right? And since the circumferences are larger, therefore, then they must have larger areas. Okay, so what is the probability they get a bullseye? Now we have some numbers. We can do some math here. So what's the formula going to be?
So you're gonna figure out the area. So the first one's pi.
Well, you got to explain to everybody.
Okay. Well, first you gotta figure out the area. Of
Area of what?
circles.
Which circle?
The bullseye.
The bullseye. So we're going to figure out the area of the bullseye. Formula is,
Pi r squared.
and the radius was
1, so it's
1.
pi.
That's where he's getting pi from.
Yeah, but
And
Okay,
also,
so the numerator is going to be pi. What's the denominator going to be?
the denominator is going to be, so first you gotta figure out the area of the second one. So that's going to be 4 pi. And
Now
then that
remember, the
minus
formula
pi
says
is
the
3
formula
pi.
says how many ways to win. Okay, bullseye over everything. Everything's the whole target.
Right.
So you just need to figure out the whole target.
so just add 2 plus.
But you gotta
is one.
minus the pi.
No. You're thinking about doing each concentric ring one at a time. Now I have seen this problem written that way. That's not what this says.
No, but you have to do it minus pi. So it's like, oh, I see.
We just need the whole target.
Yeah.
So that's just
So it's 9 pi.
So it's not bad. Now, what he just said about, hey, look at the concentric, how much area is in this middle ring, how much is there? Absolutely 100%. Because the question can say, usually it'll be like, they'll show points and they'll say, what's the probability that you get, 1 in the outer and then, 1 in the inner. And then you would have to do that. Okay. This one, we just have the whole thing. So numerator is pi and the denominator is, 3 squared pi, which is 9 pi, which would just, the pi's would cancel and you're left with 1/9. Which is not a huge number, but it's also not really small. 11% chance of getting a bullseye if you hit the target.
Uh-oh.
deceptive.
Well, what if I'm bad at hitting targets?
That's why they had to have this. If the beginner shoots an arrow and hits the target, you know, the classic, they let the string go and the arrow stays there and it just goes doing. We used to, my old school, we had one of the quarters for PE, they would have archery. And I used to I never would go inside the gym. They shot inside in the gym. And I would never go inside because I was like, somebody's going to die in there. Like a whole bunch of 7th and 8th graders shooting real arrows at real targets. Nobody died though. All right, this is the last one. It's actually pretty challenging to figure out. I'm going to see if you guys can.
I won't say anything, but
If you guys can figure it out yourself, I would be impressed. And it's also pretty cool. How many people have been to the fair before, or the carnival, or something like that, where they have those games of chance? You been to one of those?
You mean the rigged games of chance?
That's exactly what I mean. You know what I'm talking about? Give me a game that you played at one of those. No. Those are.
Or throwing the balls at the
Cornhole.
Clowns, and then you knock them over, and then
Right. What's the percentage of people winning there?
like
Zero.
zero.
Like zero, right?
Zero.
It's
So
like the house always wins. You never gamble.
right. That's one of the tenets of a good business is that if you have anything to deal with gambling, you make sure that your percentages are higher than the players, and therefore it's literally got a math term called the law of large numbers. And the law of large numbers says is that the more times that you play the game, the closer that your results reach the expected probability. So like flipping a coin, right? If you flip it twice, you can get 2 heads in a row, really easy, right? But we expect after, a billion flips of coins that the percentage of heads versus percentage of tails is 50-50. So the more experiments that you do, the closer it gets to 50-50.
But what if you go?
That's how casinos make their money.
Yeah, because
I mean, you can easily win money at a casino anytime, but because they have so many people play it, that eventually the results match what the expected probability is, which is, I mean, they can have probabilities of winning as high as 40-45% and still make money because they have enough people to play the games.
Unless you go against Ocean's 11.
And the classic one that everyone gets wrong is, I flip a coin, pick a number, 20 times, and I get 19 heads.
Holy snap!
And I want you to bet $100, McKinley. What are you going to bet on the next coin flip? I got 19 heads in a row. What are you going to bet?
$100.
That.
That.
The next one is
Tails.
A head.
you.
I would not bet.
No, I'm forcing you to bet now.
I would not.
I'm forcing you to bet.
It
Yeah,
wouldn't
yeah,
matter.
yeah.
I
Come
would,
on, you got to stick with
I
it.
would
bet
bet
on one.
$1,000.
Are you
going to
bet
get
that
a
it's
head.
heads or tails?
I'm betting $1,000 you're gonna get a head.
All right, I'll play with your game. It's a tail.
Tails.
Heads.
Okay, now I'm going to change the bet. Are you more likely, you got 19 heads in a row, are you more likely to get tails, heads, or does it matter, DM? Now what's your bet?
Doesn't matter.
Doesn't matter.
Doesn't matter.
This doesn't matter. Why?
Because you're just flipping. It doesn't matter what you got in the
The
past.
coin isn't alive. I'll just say, this is the one question that
The coin isn't a
separates
math teacher.
people who can think this through and people that can't think this through. Most human beings would bet tails. Because you can't get 19 heads in a row and the next one not be tails. They think that the previous 19 flips has some influence on the coin.
Yeah,
It,
nah.
it doesn't.
But it doesn't.
It's a random.
The
right?
coin doesn't care.
The coin doesn't care, nor does it know what you flip. Okay, back to the hard problem here. So this is one of those fair games. I have seen this one. This is also like the one where they have like Coke bottles all up here. You're throwing these little tiny rings,
Oh yeah.
and you have to lay it right there. It's
I
impossible,
hate that one so
Impossible.
much.
right? Yet people play it all the time, right? So at a carnival, you're going to toss a coin, a dime, onto a table. On the table, it's like it's got the coordinate plane with all the little squares. The squares are 30 millimeter by 30 millimeter, and dimes are 9 millimeter. So what's the probability? Here's the picture. What's the probability that you don't land on a black line?
Well, I would say there's an infinite amount of possibilities for both.
Yeah.
But that's true. Like you're just gonna.
But on a 30 millimeters on each side.
Right.
How about now?
How in the world will we even approach this? By the way, notice it doesn't tell us how wide this is. It simply says that you have a grid of squares. Okay.
Saw you reading it.
Well, I've already been reading it. I'm not allowed to answer this.
Then why
And I
do
know
you
the
keep
answer.
answering it?
I'm not answering it. I'm just questioning why are you saying infinite when it's only 30 millimeters
Because
on
it
each
is an
side?
infinite amount of possibilities.
What do you mean by infinite amount of
You
possibilities?
can hit it here, or you can hit it slightly, very slightly.
Okay, I got you.
Very-
I will agree that there are an infinite amount of possibilities. Agreed.
But we're not talking about infinite. We're talking about the probability.
But we're saying of those infinite amount of possibilities, which ones win versus what can happen.
It would be how many? So,
Like I said, notice it doesn't tell us how many of these squares there are.
so the area of the coin has to fit within the area of the.
That's exactly right. The area of the coin has to fit, but wait a minute, one's a square, one's a circle.
Uh-oh.
So here's the idea. Now, it's a tried and true technique in math that when you have a word problem and you don't know what to do, it's called make the problem simpler. So we're going to make this as simple as possible. Instead of having an unknown number of squares, how about we make it,
Circles. One circle.
that would make it really easy.
One
Right?
square.
We can't really change the thing. Let's make it one square. So we're going to make one square, and inside this square, we're going to, where could the coin go? To win versus losing.
To less than tangent to any of those.
Well, here's my
Not
coin
touch.
right now, right? We know that how far is it this way?
30,
And how far is it up and down?
30,
And we know the coin is from here to here.
9
Okay. So where could the coin go?
within the area.
I mean, it could go right up to this corner, and when it was, how far would it be away? If it was matched right up here, how far would it be away this way?
Well, you're getting into the question. Achilles could never cross the legs.
No, we're not going there, but I like to call it. If I went right to this corner, how far would the center of the coin be away from the side?
Very, very small amounts.
Which is.
Which is
A tiny 1 millimeter. I don't know.
Yeah.
I'll draw it for you.
Please
So
draw. 'Cause I don't think you
if I'm
understand.
right there, how far am I away from that side?
No, I don't understand what you're saying.
If the coin
You're
is as
not.
close to the line as possible without touching, how far are you away?
You're not. You're like very one like
From
a
the
bajillion.
middle of the coin.
How far are you away from the
9.
side? You're 9. Not only am I 9 from that way, how far am I away that way?
Well, yeah,
9.
I figured.
Okay.
I
What if the coin was over here?
Still be 9.
And then from
so you
here?
have to, so you have to subtract. I get what you're saying.
And then
So
from
9.
here?
9. So
And
you
then
have
from
to.
here?
So you have to do it so that you calculate the area and then
So anywhere along here I would be good. Anywhere along here, anywhere along here. So in fact, what you would make is
a 21 circle.
you make that shape and you'd be good to go. As long as the center of the coin was anywhere in this dotted line square.
Right.
So now there's my crummy picture. And so Madison's wondering what the heck I just drew. That's what I drew. There's it in perfect dimensions. So we made the problem a whole lot simpler, right? Instead of drawing a whole bunch of squares, we drew one of the squares. And if the center of your coin is where, you win.
In the middle of that 12.
somewhere touching that 12.
Somewhere in the red, right? As long as I'm touching somewhere in the red, I win. So that would be the area for winning. What's that area?
Is 144.
And the area of losing would be, what could happen if I play the game would be the entire square. What's the entire square?
900.
Okay.
So it's 144 out of 900.
Now that's for one square. Now what changes when I do this on a larger? It doesn't change because all the squares are the same size.
Right.
So here's your classic example of, boy, this is a seemingly really challenging one, and it is, right? The way you solve it is you make it the easiest possible problem.
72 over 450.
And that turns out to be 16%.
Take our homework.
By the way, 16% that's probably not one of the games that we play because 16% is, you got a good chance of winning that. Not more likely to win than lose, but I bet all the carnival games are probably in the single digit percents.
Yeah, like one of them, it says it's the same for number 9 and number 10. It's the same problem, but with different one of them, with different points. The first one is like a quarter, and holy snap, that's a low percentage.
Right.
A quarter.
Well, they make the rewards so good because then you don't think about the percentage.
Yeah.
Thank you.
Really.
Plus, if you gamble, and then I have a magnetic dice to use to win every time. If only I could get.
Yeah, that's true. Carnival games could be great. Then
Yeah.
You could buy unfair dice. I'm sure they sell them. They sell cards like that.
Magnetic cards. Oh, wow, that's illegal. Okay.
Oh, that's what magicians use.
Oh, okay. Okay. Oh, research that.
She just asked me how to go. Last year I had to watch that like take it apart and had a knife in it. That was awesome. That's pretty good actually.
Somebody,
What?
no, somebody took the controller. No.
I hit my brother.